Hello friends, in this session we will see some examples where our 4-step method is not applicable. Along with that, we will also see some exceptions where it is very difficult to draw a polar plot. Let's begin. So if you remember, we had a 4-step method to draw the plot, right? What was that method? Let us quickly revise that. Let us do that. If you remember, the first step or the zeroth step, if you know, it was what? That you have got this GH of S, right? So you were supposed to replace S by J omega such that you get GH of J omega, right? Right. This was the zeroth step. The first step that we had, step 1, S1, was what? Was that to find M0 and to find M infinity. M0 is what? M0 is the magnitude of GH at omega equal to 0, right? And M infinity is what? Magnitude of GH at omega equal to infinity, right? And then after having those, after finding M0 and M infinity, if M0 is greater than M infinity, then next steps can be applied, right? Yes. And then we had seen this step 2. Step 2 was what? Step 2 was nothing but to find phase, that is phi 0 and phi infinity. What is that? So angle, angle of GH at what? At omega equal to 0 is our phi 0, right? Similarly, if you think of this, it is what? Angle of GH at omega equal to infinity. It is what? It is nothing but phi naught. Is that correct? Yes. Now we had also seen that here itself we had seen that the type of that particular loop gain or that type of the system that we get is nothing but n, which is equal to modulus of phi naught by 90 degrees. Is that correct? Yes. Then after that, we had seen that if you are supposed to, or if you are interested to find number of poles minus number of zeros, that is nothing but p minus z. Yes, now this everything is with respect to loop gain itself. So if you are interested to find the number of poles minus number of zeros, then it is equal to what? It is equal to phi of infinity, or you can say phi infinity by 90 degrees, mod of infinity by 90 degrees, right? Yes. Now the step 3. Step 3 was what? Step 3 was to find ending direction. To find ending direction. In order to find the ending direction, we used to do what? We used to do phi infinity minus phi 0, right? Yes. If this subtraction, if this is positive, if this comes out to be positive, then ending direction is going to be anti-clockwise direction, and if it comes out to be negative, then the ending direction would have been clockwise. We have seen that, right? Yes. And then the step 4, which was the last step, which was to find the starting direction. So here we had seen that we need to ignore the poles or zeros on the imaginary axis, right? And whatever is closer to the origin, if we see that in our pole 0 plot, in our pole 0 plot, if we see that pole is closer to origin, pole is closer to origin, then the starting direction is what? Clockwise. Whereas if 0 is closer to origin, 0 is closer to origin, then it is going to be anti-clockwise direction. Is that clear? Yes. Now this particular four step method which was applicable to, it was universally applicable, right? Yes, even this has some limitations. Even this has some limitation. The first one is what? The first limitation is what? Yes, this m0 should be greater than m infinity. Yes, we have already seen that, right? But apart from this, there is one more limitation, and that particular limitation is what you need to understand this. You please write note. That particular limitation is what it is. It is that you cannot apply this, cannot apply if poles are on right half of S plane. If poles on RHS right half of S plane, right, right half of S plane. I hope it is clear. This is the note which you have to put. That yes, this is the limitation in such examples where poles, where the open loop poles or the loop gain poles which are there, if they are on the right half of S plane, then in such cases our four step method is not applicable. Then in such cases, what has to be done? Let us see that. If I think of the first example, let me write, right? So by observation, you see that the denominator is what? S squared minus 1. So if you equate it to 0, it will give you S squared equal to 1, which means that there are two poles on the right half of S plane at 1, right? See here, if you equate this denominator to 0, what do you get? You get S squared minus 1 equal to 0, so you get S squared equal to 1, right? S squared equal to 1, so you get S equal to plus or minus 1. Is that correct? Yes. So if you see here, it means that there is one pole on the right half of S plane. Yes. So I had told you that we cannot apply that four step method here. If we cannot apply that, but then let us start. Let us start with it and then try to understand the things, right? Let us see that. So as usual, if you see, the first step is what? To find the magnitude. What is the magnitude here? Rather, the zeroth step was what? To find gh of j omega, which is equal to what? J omega plus 2 upon j omega squared minus 1. If you think of this j squared, this is j squared, right? J squared is what? It is going to be minus. So what we get here is nothing but j omega plus 2 upon minus omega squared minus 1. This is what is gh of j omega. Is that correct? Yes, this is our gh of j omega. Now I am interested in the magnitude and phase. So if I want the magnitude, what is the magnitude here? Magnitude is going to be what? Yes, if you see the numerator, in the numerator of gh of j omega, we have got j omega plus 2, which means real part is 2, imaginary part is omega, so it is nothing but under root of real part squared plus imaginary part squared. Real part is 2 squared, 2 squared is what? 4, so we get 4 plus imaginary part is omega, omega square is nothing but omega square divided by what? Yes, in the denominator we have got these terms, so we will have magnitude to be equal to. So if you think of the denominator, what is the magnitude of the denominator? It is going to be omega squared plus 1. That is nothing but the magnitude. If you think of angle phi, what is angle phi? Angle phi is going to be what? Yes, it is going to be, numerator angle is what? Contribution of numerator angle is what? Tan inverse of imaginary part by real part. So it becomes tan inverse of, what is imaginary part? Omega divided by 2, right? And here if you see, we have got this minus sign. What does that indicate? Or you can also keep this as, let us say, minus into omega squared plus 1. Is that correct? Yes. So this minus sign indicates that it is going to be 180 degrees. So minus sign indicates 180 degrees, right? If that 180 degrees goes in the numerator, you get minus 180 degrees. So here minus tan inverse of omega by 2 minus 180 degrees. This is the phase. This is phase phi. This is magnitude m. Is that correct? Yes. Now, step 1. As usual, step 1 is what? To find m0 and m infinity. Let us find that. So let me do the step 1. Step 1 was to find m0. What is m0? m0 is what? Magnitude at omega equal to 0, which is nothing but what is at omega equal to 0. This is the magnitude. If you see, this is the magnitude. So in this magnitude, if I put omega equal to 0 in this equation, what I get is under root of 4 plus 0 divided by 0 plus 1, which is nothing but equal to 2. Is that correct? Yes. Now if I am interested in finding m infinity, how to find m infinity? What is m infinity? As usual, m infinity is nothing but magnitude at omega equal to infinity, which is equal to what? If you put infinity in this equation, what do you get here? You get under root of 4 plus, in place of omega I am supposed to place infinity, so it becomes 4 plus infinity divided by what is having infinity. Infinity is infinity. Infinity by infinity. What is there? Indeterminate form. Indeterminate form, right? So in such a cases, what are we supposed to do? We are supposed to take omega common, right? Because this is infinity by infinity form, which is indeterminate form, right? So in such a cases, indeterminate form. So in such a cases, we take what? We take omega outside. So if we think of that way, so it becomes, if you think of, this is 4 plus omega square divided by omega squared plus 1, right? If you take this omega out, so we get omega under root of, what do you get inside? You get 4 by omega squared plus 1 divided by omega squared plus 1. Is that correct? Yes. Now if you think of, if you take, even from here, if you take this omega outside, you get omega into 1 by omega. This is what you get. So if you just place this omega, now if you apply at omega equal to infinity, if you put, you get this term to be cancelled. Omega gets cancelled. Inside what is happening? This becomes infinity, so this complete term becomes 0, right? Similarly here, if you see, this term becomes infinity, so infinity, and this term becomes infinity, so infinity plus 0, which is infinity, and this is nothing but 1 by infinity, and 1 by infinity is nothing but 0. So you understand that m infinity is equal to 0, whereas m0 was 2. Is that correct? Yes. Now if you think of step 2, step 2 is what? Angle, or we can say phase at omega equal to 0 and phase at omega equal to infinity. If you think of that way, so you get step 2. Step 2 is what? So step 2 is what? To find phi 0. What is phi 0? Is nothing but phase at omega equal to 0. If you think of phase at omega equal to 0, it is nothing but, yes, tan inverse of omega by 2. Let me take another color, green. So this one, let us focus on equation of phase. You get tan inverse of omega by 2. If you think of tan inverse of, so it becomes tan inverse of 0, right? Minus 180 degrees, so it becomes minus 180 degrees, which is equal to what? Tan inverse of 0 is nothing but 0, so you get it to be equal to minus 180 degrees. Is that correct? Yes. Now let us find phi infinity. What is phi infinity? Phi infinity is nothing but phi at omega equal to infinity. So if you see, if you replace omega by infinity in angle equation or in phase equation, we get, see, this is the equation, tan inverse omega by 2, so it becomes tan inverse infinity minus 180 degrees, which is nothing but tan inverse infinity is what? 90 degrees, so it becomes 90 degrees minus 180 degrees, which is equal to minus 90 degrees. Now here is the problem. You cannot apply step 3 and step 4. You cannot find ending and starting direction. Why? Because it's the rule. Or you can say that it is because you have one pole at right half of S plane. That is the reason it cannot happen. So now there will be four different cases which can occur. What are those cases? We will try to understand. Let us see them in detail. See, yes. So if you see here, we have seen that m0, which is magnitude at omega equal to 0, is nothing but 2, right? And at infinity it is going to be 0, which means that my plot has to start at 2 and it has to end at 0. Is that clear? Yes. Now also, if you see angle, angle is what? Minus 180 degrees, right? Minus 180 degrees, and the ending angle is what? Minus 90 degrees. That is for sure. Which means that see, now we don't know the starting and ending direction, but we know the starting and ending points. What are those? See, the first one, if you see the magnitude at omega equal to 0, it was equal to 2. It was equal to 2. Yes. But the angle was minus 180 degrees, which means it has to be here somewhere. This is nothing but that 2, because it is 2 at an angle minus 180 degrees. Is that correct? Yes. So, yes, that is nothing but 2. Now, what is the ending? Ending is at 0, magnitude 0. What about angle? Angle is nothing but minus 90 degrees. So, angle 0 at angle minus 90 degrees is nothing but 0 only. Right? This center. I hope it is visible, right? Yes. So, if you see here, either this plot, because the ending directions and starting directions are not known, because it is not applicable, so in such a cases we have a special method which has to be used, and that is what we will see. So if you just observe here, either it can go this way, right, or means this way, in the sense either it can move in this direction, right, or it can move in this direction, because the starting and ending points are 2 0, that is for sure. Or it can also move like this, or it can also move like this. Is that correct? Yes, this can happen. Definitely this can happen. Now we need to check whether it is perfect or not. So for that, let us start with the third and fourth case. Let us start with third and fourth case. If you observe in the third and fourth case, we see that at some frequency omega, we don't know the frequency. At some frequency omega, the plot crosses 0. The plot crosses minus 180 degrees, right? At some frequency omega, the plot crosses minus 180 degrees axis, which means we need to use angle criteria, right? So to check that by angle criteria, let us do that. So we know that phi is nothing but tan inverse of omega by 2 minus 180 degrees, right? So if I put phi equal to minus 180 degrees, so I need to check, right? I need to check whether there is any frequency, apart from omega equal to 0, because we know that it is starting at here, right? Which means, or we can say here itself, yeah, omega equal to 0, and this is omega equal to infinity for that matter, right? Definitely, because starting here and ending at infinity. So yes, at omega equal to 0, apart from this omega equal to 0 frequency, is there any other frequency for which my plot will intersect the minus 180 degrees axis? So in order to check that, we will use the angle criteria. So I have put the phase to be minus 180 degrees, and now I will try to find that particular frequency. So that is nothing but here, yes, tan inverse of omega by 2 minus 180 degrees. So if you see here, I have got this minus 180 degrees will get cancelled, so you get this to be equal to 0. So you get tan inverse of omega by 2 equal to 0. So you get tan inverse of omega by 2, which is equal to 0. So you get omega to be equal to 0, right? Now, if you see omega equal to 0, omega equal to 0 has been already taken into consideration, has been already accounted for. Why? Because at omega equal to 0 only it is starting at magnitude 2 and at angle minus 180 degrees, right? So this particular frequency has already been taken care of, but there is no other frequency for which the polar plot is moving or it is intersecting the minus 180 degrees axis, which means 3 and 4 are not valid. You see that 3 and 4 are not valid because there is no intersection, which means 3 and 4 are both discarded. Now let us think of first and second. What happens there? Yes, so if you check, see, we have known that this is omega equal to 0. See here, this is omega equal to 0, this is omega equal to infinity, right? Similarly, this is omega equal to 0 and this is omega equal to infinity, right? Now let me assume any other frequency, or we can say any frequency between omega equal to 0 and infinity, means between 0 and infinity. Let me consider any one frequency, and let me check the angle for that frequency. If that angle comes out to be lying somewhere between minus 180 degrees and minus 270 degrees, then second one will be right. And if that angle comes out to be between minus 90 degrees and minus 180 degrees, then case 1 has to be right. So let us do that, right? So if you say here, yes, we already have this phase which is nothing but tan inverse of omega by 2 minus 180 degrees. So for simplicity, let me just replace omega by 2 only. Let me just put omega equal to 2. If I put omega equal to, what I get is I get tan inverse of, because see, I have to put any frequency between 0 to infinity, any other frequency, and I need to check the angle. If the angle is between minus 180 degrees and minus 270 degrees, then definitely second one is going to be the right. And if the angle comes out to be between minus 180 degrees and minus 90 degrees, then definitely this one will be right. So let us check that. So if you check here, you get tan inverse of omega by 2, that is 2 by 2 minus 180 degrees. 2 by 2 is nothing but 1. So tan inverse of 1 is going to be what? 45 degrees. So you get 45 degrees minus 180 degrees, which is equal to minus 135 degrees. What does this mean? If you see, minus 135 degrees comes where? Minus 135 degrees comes here, somewhere here, right? Because this is minus 90 degrees. So here somewhere we are going to have minus 135 degrees here somewhere. This angle is going to be somewhere minus 135 degrees, which means case 1 is right and case 2 is discarded. So this is a way in which we can check, or we can draw the plots for a system which is having its open loop pole on the right half of S plane. Is that correct? Yes. Let us take one more example and try to solidify this one, right? Let us take one more example. Yes, so here also you will see that in the denominator this is s minus 4, which means what? There is a pole at 4, which is nothing but right half of S plane. So there is a one pole on the right half of S plane. Is that correct? Yes. So in such a cases, the way which has to be adopted, we have already seen that. So let us apply that way and try to find the plots, right? So the first one is what? To find gh of j omega. So we know that gh of, let me take another color, gh of j omega is what? J omega plus 2 divided by j omega plus 1 into j omega minus 4. Is that correct? Yes. Now let me find the magnitude and phase. So what is magnitude? Magnitude is going to be what? If you see, this is the real part and this is the imaginary part, so you get magnitude to be equal to under root of omega squared plus 4. divided by, again this is the real part and this is the imaginary part omega, so you get under root of what, omega squared plus 1, multiplied by, again you get under root of 4 squared and omega squared, because 4 is the real part and omega is the imaginary part, so you get this one as omega squared plus 16. Is that correct? This is the magnitude expression we have got. Now let us find the expression for phase. Phase expression will be quite bigger here. Let us check out phi. Yes, if you think of phi, it is going to be what? It is going to be what? The first one, let us think of the numerator. Think of the numerator, it is just going to be tan inverse of omega by 2, imaginary part by real part, right? It is taken into account. What about this one? This pole is also, yes, it is j omega plus 1, so it is also going to be minus tan inverse of omega by 1, which is tan inverse of omega. Now here comes the thing. Here comes the thing. What is the angle for this one? Last one. If you check out, it is j omega minus 4, right? Yes. Which means it is in which quadrant? See, if you see here, real part is negative, imaginary part is positive, which means it is in this quadrant, which is nothing but the second quadrant. It is in the second quadrant, right? Because in the second quadrant, because this is real axis, right? So negative real axis is here and this is going to be positive y axis. So yes, definitely it is in the second quadrant, right? So angle is going to be somewhere here. So in such a cases, what we do is we add 180 degrees, or the angle that we get is nothing but this. If you can see here, the angle that you get is this, red. Let me take another color. The angle that you get is this one, right? So that particular angle, because see, because at the end you want this angle. What angle? At the end you want this angle, right? So total angle is 180 degrees, so it is 180 degrees minus, what is this angle? This green is given by tan inverse of whatever is this one. Yes, it becomes omega by 4, so it is imaginary part by real part, which is omega by 4, right? If this one goes in the numerator, because it is in the denominator, right? When this goes in numerator, we get it to be equal to minus 180 degrees plus tan inverse of omega by 4. This is minus 180 degrees. I hope it is clear, right? This is simple basic mathematics which you should know. You should remember this, right? Anyways, so for this angle it comes here to be minus 180 degrees plus tan inverse of omega by 4. Is that correct? So this is nothing but your phase phi. Now, as usual, step 1 is what? To find m0 and m infinity. Let us find that. Step 1. To find m0. What is m0? m0 is nothing but magnitude at omega equal to 0. What is that magnitude? It is nothing but equal to, see, this is the magnitude, right? If you put 0 in place of omega, this blue, if you put 0 in place of omega, you get under root of 0 plus 4 divided by under root of 0 plus 1 into under root of 0 plus 16, right? Which is equal to what? 2 divided by 4, which is nothing but half, which is nothing but half. So step 1, yes. Now what is m infinity? M infinity is nothing but magnitude at omega equal to infinity. What is that equal to? What is that equal to? That is nothing but equal to, in place of omega, if I put infinity, what do I get? That is the thing. So if you see here, you have got basically these two poles, right? So if you think of, one omega will come here out from this, one omega will come out from this one, because this is omega square. If it comes out, it will become omega. Again, this will become omega, so omega will get cancelled. But here you have one more term, right? Because of which this omega square, when it comes out, it will again become omega, which means in the denominator you are going to have omega, which means if you place omega as infinity, what you get is some number that is under root of 4, which is nothing but, let us say, 2 by infinity, which is nothing but equal to 0. If you don't understand it, let me solve this for you. See, we know that m is equal to under root of omega squared plus 4 divided by under root of omega squared plus 1 into under root of omega squared plus 16. Is that right? Yes. Now, if you take omega common from the top, this is omega squared. If it comes out, it becomes omega. So it becomes omega into under root of omega squared by omega squared is nothing but 1 plus 4 by omega squared. Is that correct? Yes. Similarly, even from here, if I take this one out, what we get is omega. Again from this one, if I take omega out, so it becomes omega. So it becomes omega into omega, which is omega squared. Omega squared by omega squared will become 1 plus 1 by omega squared multiplied by under root of 1 plus 16 by omega squared, right? If I replace omega by infinity, what we get is, if I replace omega by because see, yes, first of all, this omega and this one omega will go, only one omega will be left, right? If I replace omega by infinity, this becomes infinity. So anything divided by infinity is nothing but 0. So you get on the top, you get 1, right? Divided by, in the denominator you get infinity. Is omega, if you replace omega by infinity, you get 1 by infinity, which is nothing but equal to 0. So your m infinity is nothing but 0. Now step 2, let us see what happens in step 2. If you check out step 2, step 2 is what? To find phi 0 and phi infinity. What is phi 0? It is phi at omega equal to 0. See, I am repeating the things again and again such that those should solidify in your brain, because in the exam you will only remember my words, you will not remember anything else. So it is very very important. Anyways, step 2 is what? To find phase at omega equal to 0 and to find phase at omega equal to infinity. So yes, let us do that. So phi 0 is what? Phi at omega equal to 0, which is nothing but, what will it keep become? See, this is the equation. For this, what will I do? Here I will put omega equal to 0 first, and then I will put omega equal to infinity, and then try to find phi 0 and phi infinity. So in order to find phi 0, I should put omega equal to 0 in this particular equation, right? So if I put omega equal to 0, I get minus tan inverse of, again, 0 minus 180 degrees was already there, plus tan inverse of 0. What do I get? Yes, this 2 will get cancelled, right? Tan inverse of 0 is as it is 0, so it is going to be, what? Because see, minus 180 degrees. Now if you check out here, everything is 0, so it becomes minus 180 degrees. That is nothing but phi 0. If I think of phi infinity, what do I get? Phi infinity is nothing but phi at omega equal to infinity, which is nothing but, yes, you get tan inverse of infinity minus tan inverse of infinity minus 180 degrees plus tan inverse of infinity, right? So tan inverse of infinity is nothing but 90 degrees, tan inverse infinity is 90 degrees, or rather, if you see, these two will get cancelled out, you have minus 180 degrees plus, this is tan inverse infinity. Tan inverse infinity is what? Tan inverse infinity is nothing but what? 90 degrees. So 180 degrees minus 180 degrees plus 90 degrees is going to be minus 90 degrees. Is that clear? Yes. So now this is where you will appreciate the method which we have learned just now. We have learned. So yes, definitely, because see, step 1, step 2 are same. You cannot find the starting direction and ending direction. So in such a cases, we will be having here, again we will be having 4 different cases. What are those cases? Let us see. Yes, so this is 0 degrees, minus 90 degrees, minus 180 degrees, minus 270 degrees. Yes, so if you check out at omega equal to 0, my magnitude is half, right? Magnitude is half, and Omega equal to 0, what is the angle? Angle is nothing but minus 180 degrees. So magnitude is half and angle is minus 180 degrees, right? So the first point we have got. What is the ending point? M infinity. M infinity is what? Magnitude at the ending point is what? 0 and angle is minus 90 degrees. It's okay. So here comes the ending point. Is that correct? Yes. So you will be having this one as half, then again this one half, this one 0, and again this one half and 0. Now again, either the plot can be in this direction or the plot can be in this direction or the plot can be in this direction or the plot can be in this direction. Is that correct? Yes. These are the only four ways it can happen, right? Yes. So now you may say that, sir, yes, the first one is the answer. Why? Because if you see the previous one, just in place of half we had 2. See, see dear, in our previous case, in place of half we just had 2, right? We just had 2. So then, and in this case, if you see, we had got the first case to be correct, right? Right, absolutely right. So will I get the same first case to be perfect now as well? We need to check. Wait, hold on, we need to check. So as usual, we will try to eliminate the third and fourth first. Check the elimination between third and fourth first. So in order to do that, we know that, see, this is omega equal to 0, this is omega equal to infinity, this is starting point omega equal to 0, this is omega equal to infinity. Again, this is starting point omega equal to 0, this is ending point omega equal to infinity. This is starting point omega equal to 0, this is ending point omega equal to infinity, right? Yes. Yes. So now if you see here, let us find that for, is there any frequency, is there any frequency except from omega equal to 0, except omega equal to 0, at which we have angle to be minus 180 degrees. Let us check that. Is there any other frequency apart from omega equal to 0 for which we have got angle to be minus 180 degrees? Let us check that, right? If there exists such frequency, then either 3 is right or 4 is right. We need to again check then, right? But for time being, let us apply that strategy. That is our strategy, right? So we know that what is phi? Phi is equal to what? Phi is equal to tan inverse of omega by 2 minus tan inverse of omega minus 180 degrees plus tan inverse of omega by 4, right? So yes, let us do that. So if we see, let me put this one phi, which is there, phi to be 180 degrees, minus 180 degrees. Let us check, right? So minus 180 degrees, which is equal to what? Tan inverse of omega by 2. It is nothing but tan inverse of 0.5. Can I write it as tan inverse of 0.5? Yes. 0.5 omega minus, can I write this as tan? Yes, this is tan inverse of omega only, minus 180 degrees, and then again this is going to be plus tan inverse of 0.25 omega, because it is 1 by 4. 1 by 4 is 0.25, right? Now let us combine, these two, this one and this one. If I combine this one, what is that? Tan A, tan inverse A. Let me write down the formula for you if you don't know, right? Tan inverse of A plus tan inverse of B is equal to what? Tan inverse of A plus B divided by 1 minus a into b. This is mathematics. This is your 10th class mathematics, right? Now, if I just do the, because see here I need to tell you one important thing. Without mathematics, you cannot do anything in control systems. You cannot do anything because it is all mathematics, all mathematics. I am repeating it. It is everything is mathematics only. So you have to have your maths perfect. Yes, at times I will help you out, but still you should be able to do that on your own. Anyways, let us move further. So if you check out, what you get here is minus 180 degrees as it is. Tan inverse of a plus b. What is a? This is a. What is b? This is b. So 0.5 plus 0.25 is nothing but 0.75 omega. Upon what? Upon what? Upon you get 1 minus ab. 1 minus ab. What is a? A is nothing but 0.5 omega into 0.25 omega. So if you multiply them, you get 0.125 omega squared. Right? Yes. Minus tan inverse of omega minus 180 degrees. Right? These two also have to be written. Is that correct? Yes. Now, if you see minus 180 degrees minus 180 degrees will get cancelled. Yes. Let me just shift this to the LHS. Then what do I get there? I get tan inverse of omega to be equal to tan inverse of. You may find this one to be quite lengthy, but it's okay. But it's okay. For understanding, it is important. Right? Now, let us apply tan on both sides. Now see what happens. If you have tan inverse of A, let us say, and if you apply tan on that, then you get A, because the tan and tan inverse will get apparently cancelled, right? So you get that A. Anyway, so if you apply tan here, what do you get here? You get tan. Let me just apply it this way. Tan of again something. So inside, let me write in red. So it is tan inverse omega, and here you get tan inverse of 0.75 omega upon 1 minus 0.125 omega squared. Correct? Yes. Now, if you see it here, tan and tan will get cancelled, so you get omega equal to 0.75 omega upon 1 minus 0.125 omega squared. Right? Yes. Now, yes, you already know that one root is equal to 0. One root has to be 0. We have already known that, right? Yes. So what will I do is, see, if you think of this omega and this omega will get cancelled. If I keep it this way, I get 1 minus 0.125 omega squared equal to 0.75. Right? If I solve this, what do what do I have? So from calculator, you will get that you get omega equal to root 2. Omega equal to root 2, which is a valid frequency, What does that mean? Because see, apart from omega equal to 0, because we know that at omega equal to 0, it is equal to, the angle is equal to minus 180 degrees, we know that. But there exists another frequency for which we have angle to be equal to minus 180 degrees, which means first case and second case are discarded. First and second case are discarded. You just see this magnitude, which was initially 2, now it is half. When it was 2, when this magnitude was 2, we saw that this first one was correct, but the moment it becomes half, this is not correct. So you have to check, always you have to check, don't become overconfident. Anyways, let us do. So now, one out of this 3 and 4 has to be correct. One out of this 3 and 4 has to be correct. Yes. That means of course definitely first and second are incorrect, right? Yes. Now let us choose 3 and 4. So let us choose omega between 0 to root 2. Now we know that here at this point we have omega equal to root 2, right? At this point we have got omega equal to root 2, right? Now let us take some frequency between omega equal to 0 and omega equal to root 2. Let us take some frequency between omega equal to 0 and omega equal to root 2, omega equal to 0 and omega equal to root 2, right? And try to find the angle for the same. So the best frequency or the best thing which we can take is 1, because 1 is greater than 0 and it is less than root 2. So let us do that. So if I check out, if I put omega equal to 1 in our angle equation, we get 5, which is equal to tan inverse of 0.5 minus tan inverse of 1 minus 180 degrees plus tan inverse of 0.25. If I just place omega equal to 1 in this one, where in this one if I put omega equal to 1, which I have put here, right? So if you place this in calculator, you get 5 to be equal to minus 184.39 degrees, minus 184.39 degrees, which is possible. Now let us see 184 minus 184.39 degrees. What does that mean? Minus 184.8, minus 184 indicates that, see, this is minus 180 degrees, right? And on top of this is minus 270 degrees, so it comes somewhere here. It is between minus 180 degrees and minus 270 degrees, which means fourth one is the answer, because here if you see between this, in this particular passage, you have this particular frequency, right? You have this one, same as this, which means case 4 is the answer. So your polar plot has to look like case 4. That is the answer. So if you observe, yes, you had 2 initially, now you have half, but still it changed, right? This is the beauty of control systems. Anyways, now let us think of one exceptional case, one special case. What happens in that special case, and then we will wrap this session up, right? Yes. Now let us consider a case of, or a special case of, transportation lag. What is transportation lag? I will explain. See, transportation lag. Let me consider an example directly. Let me consider GH equal to e to the power minus st upon s into s plus 1. Let us take this example so that you will understand it in a better way, right? Of this, if you see the numerator, this e to the power minus st is nothing but the transportation lag. This is called as a transportation lag. What happens if you have such a kind of transfer function or this loop gain? What happens? Let us see. So the first thing which we do is gh of j omega, so let me just replace s by j omega. So you get e to the power minus j omega t divided by j omega into j omega plus 1. This is what is there. Now as usual, let us find the expression for magnitude is what? M, which is equal to, yes, what is the magnitude for numerator? If you remember, in complex numbers we have something called as exponential form, right? Exponential form, wherein we write things as r into e to the power I theta, right? So in this particular, whatever is there with e is nothing but the magnitude, this r is nothing but the magnitude, whereas this theta is nothing but the phase. Is that correct? Yes. So if this r is the magnitude, then what happens with e? What you have? You have 1 here, which means magnitude is going to be 1 for the numerator. What about denominator? Yes, magnitude of j omega is nothing but omega, right, multiplied by under root of what? J omega plus 1, which is nothing but under root of real part squared plus imaginary part squared. So it becomes, let us say, omega squared plus 1, or vice versa, right? This is magnitude. Now let us think of angle phi. What is angle phi here? Angle phi is going to be what? Yes, angle phi is going to be, for this one, I just told you that here, if you see, I explained that r into e to the power I theta, and this theta is nothing but phase. So theta is that number which is there with I, with that imaginary number. So with j, what we have is omega t. So which means it is going to be, or rather I have minus omega t with it, right? Minus omega t is there with j. So which means that the phase is going to be minus omega t for the numerator. What about denominator? You have this j omega. This j is nothing but 90 degrees. Going up, it becomes minus 90 degrees. So we have this one as minus 90 degrees. Again, this one, j omega plus 1 is what? Tan inverse of minus tan inverse of imaginary upon real. So it becomes omega by 1, or omega. Is that correct? Is that correct? No. Why? Because if you see, these all are in degrees, whereas this one is in radians. Right? So I need to convert it from radians to degrees. So in order to convert it, what do I do is, let me write down the expression phi again, right? So in order to convert it from radians to degrees, what will I do? I will multiply by 180 by pi. That's it. This becomes your phi. Is that correct? Yes. Now let us apply our 4-step method, right? So step 1. Step 1 is what? To find m0, which is nothing but magnitude at omega equal to 0. How do you find that? How do you find that? If you put omega equal to 0 here in this expression, you get 1 by 0 into under root of 0 plus 1, which is nothing but 1 by 0, which is equal to infinity. What about m infinity? M infinity is going to be what? M at omega equal to infinity. What is that? What is that? See, m at omega equal to infinity. So if I put here infinity, I get 1 by infinity into infinity plus 1, which is equal to 1 by infinity, which is nothing but 0. So if you again see here, m0 is greater than m infinity, which means next steps can be followed. Yes. Now let us think of step 2. Step 2 gives you the angles. So the first angle is what? Phi 0, which is nothing but phi at omega equal to 0. What is that equal to? So this is it. So if you just put omega equal to 0, you get minus 90 degrees as it is. See, here in place of omega t, here if you put omega equal to 0, this term becomes 0. So now we are minus infinity, and then again minus tan inverse of 0. So tan inverse of 0 is again 0. So what you get here is minus 90 degrees. Now let us think of phase at infinity. Phase at infinity is equal to what? Phase at omega equal to infinity, which is equal to what? Minus. So this here is the problem. Here is the problem. See, when you put this minus omega t, if you put omega equal to infinity, you get phi equal to infinity. Please mark this in pink red, whatever you want. This is where the problem is. This is where the problem is, right? Because the angle is infinity. Because see, if you just think of one complete circle, it is nothing but from 0 to 360 degrees. So in such a cases, how to plot a polar plot? Let us see. So in such a cases, the polar plot that is there is going to be how? I will tell you. Let me draw the polar plot. I know that this is going to be 0 degrees, this is minus 90 degrees, this is minus 180 degrees, and this is minus 270 degrees. Is that correct? Yes. Now let me draw the polar plot. What is m0? What is m0? M0 is infinite. And what is angle at that time? It is going to be minus 90 degrees, which means at minus 90 degrees it is going to be there. Right? What is starting direction, ending direction? What is starting direction, ending direction? Starting direction is what? starting direction will be given by whatever is there closer to origin. So if you see closer to origin, because see we have s plus 1, so closer to origin we have this pole, right, which means it is in clockwise direction. See, because if you think of the polar plot sigma j omega, then the pole that you get is going to be here, right? So the first thing that you see is going to be the pole, so it is going to be clockwise direction. So starting direction is clockwise. So if you see, this one starts here this way, and it goes and it makes loops infinitely. See, angle is increasing infinite, and this becomes here, goes here, and it ends at infinity. I hope you are understanding my point. So this is the direction, this is the direction, right? This is the direction. So if you see, this is the polar plot. Now student may ask me, sir, what if here in place of minus st, if I have plus st, if you have plus st, no, then this direction will become anti-clockwise. It will just reverse, that's it. Rest everything will remain same. So this is the polar plot for transportation lag, which was a exception case, which was a special case, right? So in this particular way we have seen different plots for systems having zeros as well as poles having transportation lags. We have also seen some special cases where that four-step method is not applicable. So this completes your polar plot. After this we will look into Nyquist plots, such that by using them we will try to understand the stability in detail, because stability using frequency domain is also very important. Thank you.